Hi all, let's get started with another Swift language video tutorial. In this tutorial I am going to talk about Boolean data type. Then there are various type of integer like 8-bit integer, 16-bit integer and 32-bit integer. Same you have unsigned integer as well. In that also you have 8-bit, 16-bit and 32-bit integer. Difference between signed integer and unsigned integer is range does not have negative values in unsigned integer, so you will always get double value in unsigned integer. Like say in signed 16-bit integer you have value from minus 327682 plus 32767, while in unsigned 16-bit integer you have value like 0 to 65535, because you need not to keep space for negative integers. Then we will look at floating point numbers. We have float as well as double data type, and how Swift language is going to handle both of these data types. We will also look into that. Then there are different types of values we can use in Swift language like hexadecimal, binary, octal and decimal. Many languages I have seen do not give you to permit Boolean numbers in their number types, but Swift do provide that facility, and I think this is very interesting and important feature of Swift language, because many times you need to do binary operations and explicitly in other languages you need to write code for that, but in Swift language you will get inbuilt support, so that's a good thing. Before we start with our this tutorial, I want to mention a very important change in Xcode 7.1 is whenever you use any older playground file, it says replace your println with print. That means you no longer need to use println, you can just need to use print. So you need to just double click here and it will fix that problem. But if you have older file, you need to definitely go and change those strings from println to print. Now let's get started with Boolean data type. So here where b equals to false. As we know from last lecture, if you don't give data type, it will infer the data type as Boolean. But here for demonstration purposes, we will actually go and mention the data type. So if say if b, then do something, I'll say print I am in true, else I am in false. Just copying and pasting the same code, else I am in false. So you can clearly see here output would be I am in false, because Boolean value is false. So if I change this value to true, you will definitely get here I am in true. Now in C or C++ language, if you have value other than 0, it is considered as true, otherwise it's false. So means 0 is false and any non-zero value is true. So even if you write -1, it is considered as true implicitly in C language. So let's try the same thing here. I do not mention any type and I suggest Swift to infer it as an integer. Now I definitely get here an error which says type int does not conform to protocol Boolean type. It simply says that you cannot use integer as a Boolean here, but I can definitely go and typecast it to a Boolean. Now it happily accept that, but you can see here value output is I am in true. If I go and change the value to 0, it will definitely go and say I am in false. If you when I give some negative value, any non-zero value will be considered as true. So I am still in I am in true. So that's about Boolean. Now we have various type of integers. Let's get little bit into it. V equals to, let's say I say int 16 or int max 16. So it will show some value 32767. Same way I say int, now w equals to int 32 max, again it will show some value First value is 16-bit integers, another one is maximum value of 32-bit integer, and yet another x int, I guess there is int 8 max, so only 127. So 0 to 127 is a range of an 8-bit integer. Same you have integer of unsigned type, u int max value of 16-bit integer is unsigned 64 integer is 65535. So you can see you can use different kinds of integer as per your need. Depending on whatever range you want, you need to use all these integers. Now you can also have, you can say, floating point number 4.5. So whenever you don't mention any data type, Swift language always treat as a double. It has up to 15 number precision, while float has only 6 number precision. So precision for float is very less as compared to double. That's why whenever you say where v 4.5 or any floating point number, it will treat as a double by default. But if you explicitly mention, then absolutely it will take it as a floating point number. So that is the only difference between float and a double. They have different precision. Float is 4 byte entity while double is 8 byte entity. There is one more difference between Swift and other languages. Like in C or C++ languages, you cannot take modulus value of and float, but here in Swift we can very easily do that. I am taking modulus of 4.5 to 3.7 and give me 0.8. In C or C++ language, or even I think in Java, it is not possible to get modulus float number. Here in Swift it is possible. Now let's move on to number types. Like you have octal, then hexadecimal, then decimal and binary. Now if you write simply say 55, it is considered as a decimal number. Now I am writing here v variable w, and I want to write hexadecimal. So hexadecimal can be written as 0x55. Now same 55 I am writing in hexadecimal, its value become 85 because it's base 16 value. Same I can do with octal, like say x 0 and o for octal. So 0 and o, and then same value 55 I am writing here, so it is taken as 45 because it is a 8 base value. Now in C or C++ language, only if you precede it with 0, then it's okay, it is considered as octal. But many times you have must have realized it leads to confusion, but it is very good in Swift language. You need to precede it with 0 and o. Same for binary, and very important, let's say word t equals to ob and some number 110010, and it is 0, it should be 0 not o. Okay, so it is giving me value 50. So it can actually take input as binary number. So that's a really great advantage over other languages, because many times you need to perform operations over binary, and this is very good if you have inbuilt support. So I think that's it for this tutorial. Thank you very much for patient listening. Keep posting your comments, like or dislike, or subscribe to my channel. It will motivate me to create more videos. Feedback is important, even though it is negative. You should always give your feedback. It will make me improve in next tutorials. Thank you very much. Hi friends, in this C++ video tutorial I am going to talk about private destructor. Now many of times you have seen private constructor. In singleton pattern you use private constructor so that outside entity of class should not be able to access your constructor. Now there is also importance of private destructor. Now let's first write down the code, and then we will see what are the ways we can make use of private destructor. Now there is a class called say CLS, and in that class I just create only one destructor, and which is also a private destructor. Now let's see how this affects rest of the things. Now I am in main and erase rest of the code which is generated by Xcode for me, and I try to simply create object. Let's say C equals to new CLS. Perfectly fine, no error, because I can very simply create an object, because constructor is public, it's not private, but destructor is private. But as soon as I go and try to delete my object here, I will definitely get error, and what it says is calling a private destructor of class CLS. So I cannot call destructor of class CLS. In the same way, I can create value on heap here, but I cannot create value on stack. Why? Because as soon as I create value on stack, this is scope delimiters. These opening and closing braces are scope delimiters. As soon as I go out of this scope, this C dies, and when C dies, it calls the destructor. Now destructor is private, so it cannot be called from main, so it gives me error again saying you are trying to call a private destructor. Now if I make it public, it will definitely allow me to create that object on stack. So we definitely see two benefits of private destructor here. One is, if you want your object should not die, your object should always reside in memory, then you should create private destructor, because no one can call delete on it in outside the class. So that's the one reason you can create private destructor. Another reason is you are not allowed to create object on stack, because if you try to create object on stack, it will definitely calls the destructor as soon as it goes out of scope, and it doesn't allow that. So you must always try to create your object on heap, because you can call new but you cannot call delete on it. So even you use pointer, it goes out of scope, it will not get deleted. That is why often you lead to memory leak, because you do not call delete here. But this is sometimes advantage also, because you want this object to reside in memory. So hope you got my point. If you have any queries, please post in comment box. If you have any suggestions or any problem regarding video, please post me that. If you like video, click on like button. If you dislike it, please click on dislike button. If you want to see more videos from me, please click on subscribe button. That only encourages me to create more videos, and your feedback is really important to me. Thank you very much.